function is going to give you a vector v of 1 by m dimensions, and it'll give you a matrix A of m by n dimensions. And when you multiply these together, you're going to get a w vector that's 1 by n dimensions. Now to do this, let's start off by writing our function title. So function, we're going to say w is equal to, now our input is going to be our name, so vec xmat, with our input, so v and a. Now, in order to do this, you have to find the dimensions of v and a. So I'm going to say the length of v, which is also its column index, how many columns it has, L is equal to length of v. Then the dimensions of a, I'm going to say m, n is equal size of a, in parentheses. Now we want to make sure that m and L equal each other in order for us to do our matrix multiplication. So we're going to say if m is equal to L. So that's our if statement. Now once we're done with all the matrix multiplication, we're going to say else dimension mismatch. So right here, we're going to start off by pre-allocating w. And why do we want to pre-allocate w? Well, you already know it's a 1 by n vector, so might as well do it to make things faster. Also, there's another reason to it. We're going to say w is equal to zeros 1 by n. Now what was the other reason? Well, when we're multiplying vector v and a, we're creating a running sum at each element. So this element is a running sum of elements being multiplied together between vector v and vector a. So it's best to initialize at 0 and make w itself the running sum at each element. So we're going to say for, and we're going to go through however many elements we have in w, and we're going to create that many running sums. So a running sum is a for loop by itself, and to find the element each element in w, that's a for loop by itself as well. So we have two for loops we're going to use. So for, I'm going to say I is equal to 1 through an n. Why are we saying n? Because we have n elements in w. Now, we already have w initialized at zeros, so we're going to use this as our running sum. So if we were not going to use w, we would say a run sum right here and make it equal to 0. But we already have zeros here, so we might as well use w itself. Then we're going to say for j is equal to 1 through, now we're going to go through m elements in our multiplication. So we'll say 1 through m. And how are we going to do this? We're going to say, well, w of I, the first element of I, is going to equal, now the first element in v multiplied by the first row in A, first column in A. So if you notice, the first column in A is equal to the first column in W. It's going to be the same index. So right here, we're going to say Wi, because this is 0, plus now V of the first element, and that's going to be represented by J. So V of J multiplied by A of, now the same row in A is going to correspond with the same element in V. So that's also going to be represented by J, and then the column in A, like we said, is represented by the column in I, which is I right here. And that's basically it. So then we end this for loop right here, and this other for loop, and then end the function. So if we end this function, or actually before we even end the function, we still have our if statement right here, because this ended right there, this ended right there. Now we still have our if statement. So if the dimensions don't match, we can just say else, and we're going to say W is equal to, and then our string dimension mismatch. So I'm just going to dimension missed, just to make it faster. And then we're going to end our function right after that, or end our if statement, then end our function. So to reiterate what we just did, we had our initial values, and then after finding our initial values, we pre-allocated W in order to make this faster when computing. Then we created a running sum off of this W using this. So this is each element in W. And then this right here is going to basically add to the running sum. And the running sum right here is equal to each element in W, essentially. And then this is whether or not our dimensions match. So dimensions don't match. And that's all there is to this function.